Good morning, students. And as I have promised you in the previous video, in this video we will discuss some particular types of divisibility tests, especially when the two-digit number by which we want to divide the large number has 3, 7 or 9 in the units place. So how to check whether a large number is divisible by a two-digit number ending by 3, 7 or 9. So first I'll take the case of 3. Suppose your divisor is of the form 10a plus 3. Your divisor is of the form 10a plus 3. So your divisor may be maybe 13, maybe 23, maybe 33, maybe 43 and so on, maybe 93. So in such a case, how to check whether a large number, suppose I am giving a large number 2, 3, 1, 7, 6, 4, 9, 8, 5 and I want to check whether this number is divisible by one of these numbers or not. So how to check this divisibility? The divisibility test, first I'll prove the theorem and then we'll discuss one or two examples and then we'll move on to the next. So the divisibility test is, the test is if, leave the if, I'm going straight forwardly, 10a plus 3 divides n if and only if 10a plus 3 divides n by 10 greatest integer minus u times 7a plus 2. So this is your divisibility test. And after proving this test, you will see amazingly how can we check divisibility very quickly using this test. So first of all, so I'm starting from here. So prove 10a plus 3 divides greatest integer function of n by 10 minus u times 7a plus 2 if and only if there exists some integer k such that this is equal to k times this. So that means if and only if n upon 10 box minus u 7a plus 2 is k times 10a plus 3 for some k belonging to the set of integers. And it is true if and only if take this u into 7a by 2 which is of negative sign here onto the right hand side and open all the brackets. So what you are going to get is n by 10 greatest integer function is equal to 7au plus 2u plus k 10a plus 3. Now multiply both sides by 10. So multiplying both sides by 10, you will get 10 here, you will get 10 here. Open the bracket on the right hand side by this 10 and add u on both sides. Add u both sides. So this will be if and only if 10 n by 10 plus u. What is u here? U is actually the last digit of the large number given. So this is the u is the last digit and a is here the tenth digit of the divisor. So 10 n by 10 plus u is equal to you will get here 70au. Here you will have 20u and you have added 1u also. So you will get 21u plus 10k times 10a plus 3 if and only if. Now look at what this number is. You have n, you divided it by 10 and taken its greatest integer function. So what you will get? You will get the number and deleted the last digit. For example, if you are having 2, 3, 4, 5, 6, suppose this is your n and when you divide it by 10, you will get 2, 3, 4, 6, 5.6 and when you will take its greatest integer, you will get 2, 3, 4, 5. So from here, what you have here now, you have only deleted the last digit, rest of the number is there. So this is that number, and then you are multiplying by it by 10. So multiplying it by 10, you will get once again 0 here, and then you have added the last digit 6. So what you will get? You will get the original number. So it will be your original number, n is equal to, here you can take something common. I think 7u can be taken as common. So you can take 10a plus 3 plus 10k times 10a plus 3 if and only if your n is equal to. Now you can factorize the right hand side very easily. It is 10a plus 3 multiplied by some integer 7u plus 10k. And it means if and only if this 10a plus 3 divides n. So 10a plus 3 divides this number if and only if your 10a plus 3 divides this number. So the test we have proved. Now the application, how to apply this test to check the divisibility of a large number by a 2-digit number ending with 3. So let us have an example. I will not take more examples. One example I think is more than sufficient to understand how this test works. Suppose your divisor is, you want to check if the number 62531, if this is divisible by 63 or not. You want to check whether this number is divisible by 63 or not. So how it can be checked? It's very easy. This is your number n. This is your number n, 62531. From here, what you want actually n by 10 greatest integer minus u times 7a plus 2. Actually you are to calculate this number again and again till this number reduces to a 2-digit or 3-digit number, from where we can check the divisibility easily. So n by 10 box, I have told you that what will be done, the last digit will be removed. So the last digit is removed, you will get 6253 minus u times, what is the u? U is the units digit. So 1 times, this is 10a plus 2, and what is a here? A is the tens digit of the divisor, so it is 6. So 7 into 6 plus 2, 7 into 6 plus 2. So what you are going to get is 6253 minus 44, so it is 6209. Still, it is not easy to check whether this number is divisible by 63 or not. So I am going to repeat the process. Repeat the process once again. So it is n dash. Suppose I am denoting this number by n dash. So n dash by 10 greatest integer minus u 7a plus 2. In fact, I should take u dash because earlier your u was 1 and now u dash is 9. So you will have to change the symbol. So what is this now? N dash by 10. Once again, this is the number 6209 and the last digit will be removed. So you will get 620 minus u dash times. So u dash is 9. 9 times 10a plus 7a plus 2. 7a plus 2 is the same. So 7a plus 2 was 44 here. So it is again 44 here. So it is 44 here. So it is 620 minus, multiply 44 by 9. So you can get easily 396. And now subtract. So subtracting you will get 224. And now you are just to check whether your 224 is divisible by 63 or not. And you know that this 224 is not divisible by 63. So your original number 62531 is also not divisible by 63. Similarly, you can check divisibility by 13, 23, 33, 43, 53, 63, 73, 83 or 93. So it is just one example. You can have more and more questions for your practice so that the process may become very easy for you and very quick for you. So in the starting it may look complicated, but as you go on practice again and again various questions, it will be very tricky and very easy and very short time taking process it will become for you. So I'm moving on to the next now. Now the next is the divisibility test by a two-digit number where the last digit, the units digit is 7. So if the units digit is 7, if the unit digit is 7, that means your divisor is 17, 27, 37, 47, 57, 67, 77, 87 or 97. Then this divisibility trick will work. What this divisibility test is? This test says that your 10a plus 3, 10a plus 7, sorry, not 3, because earlier it was the last digit 3 and now the last digit is 7. So 10a plus 7 divides n. If and only if 10a plus 7 divides n by 10, greatest integer minus u times 3a by 2. So this divisibility trick will work when your units digit in the divisor is 7. So let us prove it first, and then once again we will have an example, and then we'll move on the next test of divisibility where the last digit will be 9. So before that, proof of this. So proof. Again, I am starting from here. So your 10a plus 7 divides n by 10 greatest integer function minus u times 3a plus 2 if and only if, once again, this number will divide this number if this number is some integral multiple of this number. So there exists some integer k such that this can be represented as k times this number. So if and only if your n by 10 greatest integer minus u times 3a plus 2 is equal to k times 10a plus 7 for some k belonging to the set of integers. The process is almost same. Once again, I will take this term to the right hand side and open the bracket. So what will I get if and only if your n by 10 greatest integer is equal to, I'm going to open the bracket, so it will become 3au plus 2u plus k times 10a plus 7, and now multiply both sides by 10. So here you will get 10, this 3 will become 30, this 2u will become 20u, and here you will get 10k. And now add u both sides. So adding u both sides, what you are going to get here is plus u. This term will be as it is. This term 20u, when you will add 1u, it will become 21u. So here you will get 21u and rest of the terms will be same. So if and only if, now you understand what this is. This is nothing but your original number n. So n by 10, that means greatest integer, that means the last digit is removed, multiplied by 10, once again 0 in the last digit, and adding you will get the original number. So this is your n is equal to, on the other side, in this you are having 10a plus 7 as a factor. Here once again you can take 3 common, 3u common. So taking 3u common, you will get 10a plus 7 once again here. So this right hand side will become 10a plus 7 into 10k plus 3u. If and only if now n is multiple product of these two. So that means n is divisible by this as well as n is divisible by this. So we need the divisibility by 10a plus 7. So if and only if your 10a plus 7 divides n. So we have proved that 10a plus 7 divides this number if and only if your 10a plus 7 divides n. So the proof is okay. Now we'll move on to one example and then on to the third and final test of divisibility when the units digit will be 9. So one example I'm going to take now. Suppose I want to check if 18761 is divisible by 87 or not. Now our divisor is 87. The last digit is 7, so the trick will work. So what we have to do, we have to calculate just n by 10 box minus u times 3a plus 2. We have to calculate this and we will repeat the process till we get a smaller number from where we can check the divisibility very easily. So here what you are going to get, n by 10. That means from this number the last digit will be removed. By taking the greatest integer you will get 1876. 1876 minus u. U is here 1. The last digit is 1 and multiplied by 3a plus 2. Your a is now 8. So 3 into 8 plus 7. So what you are going to get is 1876 minus, this is 24 plus 7 is 31. So minus 31, that means 1845. Now your new number is 14845, but still divisibility of this number by 87 is not easy. So once again we'll repeat the process. This is your n dash now and this 5 is your u dash. So now you have to calculate n dash by 10, greatest integer, minus u dash, and 3a plus 2 will remain same. So n dash by 10, once again from here the last digit will be removed, the rest of the number will be 184 minus this u dash is now 5 and within the bracket this 3a plus 2 you will get the same term, that means 24 plus 7 is 31. So what you are going to get is 184 minus 5 into 31 is 155 and subtracting you will get 29. Now your 29 is not divisible by 87. Don't see other way, because 87 is divisible by 29. But you have to check whether 29 is divisible by 87 or not. So the answer is not. This 29 is not divisible by 87 means this number 18761 is not divisible by 87. So this was the test if your units place is occupied by the digit 7. Now the third test, if your divisor is a 2-digit number and the units place is occupied by the digit 9, then the test is now, I'll write first units digit of divisor is 9. Then your test says the number will be of the type 10a plus 9 now. So 10a plus 9 divides n if and only if 10a plus 9 divides n by 10 greatest integer function minus u times 9a plus 8. This is the test. Now this is the trick. This will work now. So let us have the proof first and then the example as we are doing in the earlier cases. So the proof of the test first. Your 10a plus 9 divides n by 10 greatest integer function minus u times 9a plus 8 if and only if this number n by 10 greatest integer minus u 9a plus 8 is equal to k times 10a plus 9 for some k in the set of integers. As we have done in the previous two cases, the same proof will work here again. Now take this term to the right hand side and open the bracket. So what you are going to get, if and only if your n by 10 greatest integer is equal to this bracket opening, you will get 9ua plus 8u plus k times 10a plus 9. And now you know what to do. Multiply both sides by 10. So here you will get 10. This 9 will become 90. This 8 will become 8u will become 80u. And here you will get 10k. And next step, once again you know what to do. Add u both sides. So adding u here this will become 81u. And now you know that this 10 multiplied by n by 10 greatest integer plus u, what it is your n, the original number. So if and only if your n is equal to, on the other side 10a plus 9 is here, a factor of the last term, and if you see the first two terms and take 9u common, you will once again get 10u plus 10a plus 9. So 10a plus 9 can be taken out and you will get 10k plus 9u. So that means n has a factorization of these two. So this means 10a plus 9 divides your n. So if and only if 10a plus 9 divides n. So we have proved that 10a plus 9 divides n by 10 greatest integer minus u, 9a plus 8, if and only if your 10a plus 9 divides n. So this was the test, and now we will take one example and then we will move on to the next. So let us see a divisor. Now what type of divisors are there? These are 19, 29, 39, 49, 59, 69, 79, 89 and 99. So we will check divisibility by any of these two-digit numbers. So we have to check if the number 28752 is divisible by 79 or not. So we have to check this divisibility now. What is your a, what is your u, what is your n? This is your number n, this 2 is your u, and this 7 is your a. And what you have to calculate, n by 10 greatest integer minus u times 9a plus 8. And we will repeat the process till we get a smaller number from where we can check the divisibility very easily. So n by 10 box, you know, the last digit will be removed and the rest of the numbers will be there. So it will be 2875 minus u times, so u is 2. So 2 times 9a plus 8. So 9a plus 8 is 9 into a is 7 plus 8. So what you are going to get is 2875 minus 9 into 7 is 63. 63 plus 8 is 71, and 71 into 2 is 142. So subtracting 142 from this number, you will get 2733. This is your new number, but still now it is not easy to check whether this number is divisible by 79 or not. So we'll have to repeat the process. So this is your n dash now, and this 3 is your u dash now, and you have to calculate n dash by 10 minus u dash, and 9a plus 8 will be the same one because a is not going to change. So n dash by 10, once again the last digit will be removed and the rest of the number is 273 minus, now u dash is 3, so 3 times, and within the bracket you will again get 9 into 7, that means 63, plus 8, that means 71. So this is 273 minus 213, so you will get 60, and your 60 is not divisible by 79. That means the original number 28752 is not divisible by 79. So these are the tricks. Using these tricks you can easily check divisibility by any of two-digit numbers ending with 3, 7 or 9. And the case of two-digit number when the last digit is 1 is being discussed in the previous video. So we have all types of divisibility of two-digit numbers, and in the next video we'll discuss more and more concepts of divisibility. Till then, thank you once again.